All right, so for people playing along at home, like Franco, sorry, dude, we still miss you. We are on student.desmos.com. The first screen that you'll see in that activity looks like the clock, the watch, whatever you want to say. And I have typed up here, I am showing what you write, so please actually care about it. So take a little bit, start working through that. Now, be careful, it's 7 miles. 7 miles. That's not a short run, right? And one thing that you could think about, have you guys done the mile run yet this year? Yeah. It's oh so fun, right?
If you got a fast time.
Well, I was being facetious because I don't like running. I run when chased. But if you know how long it took you to run your mile, you might be able to use that to help make your prediction. But go ahead, take a minute. I'm going to start to share these as soon as they kind of start popping up. So I will anonymize us because I'm recording and I don't want to share your guys' names. But as you type, it pops up here. So just be aware, I see as you go. But it doesn't matter, right or wrong right now. We're just making predictions, right? A lot of these activities in Desmos are designed with a guess too high, too low, and then figure out what it's actually supposed to be. So while you guys get started on this activity, I am going to pass off papers. I was wondering why it was so quiet in here. What? What's up, Eve? Oh, it should be assigned to you. So if you go to your student homepage, so hit login. I'm going to log in with Google. And then we're going to go to the student homepage. Hey! Olympic runners. I mean, it does this weird thing where it might make you hit it a couple times and then the running. Hey, so there is a space to. Hey, there's a space to defend why you said what you said, and it will show up to your classmates. So you don't have to talk about it with your desk mates. Don't make me regret leaving the desks in clusters. You did a bunch. Way to go, man. Nice. Yeah. I heard my name, but I don't know from where. You can use a calculator if you want, but we're really just predicting right now. Hit that. Actually hit that. Anyone else's Desmos is broke. I know sometimes Desmos breaks as we're trying to get in. Alright, I'm going to start to put your responses on the board. Let's see how fast we think people are. So we got 90 minutes as a guess. It took me 4.5 minutes to walk each lap. So, be careful though. Were the laps a mile in length? It does not matter if you're wrong right now. It does not matter. 14 minutes would be pretty fast. 49, 80, 45. So once you've made your prediction, go ahead and move on to the next screen and talk about why, right? What information? So if you look up here and you see that something's already up there, try to think of something else. So things that people have already said is his age, how long his legs are. Something else could relate to how long your legs are. Maybe is he athletic? I don't know. So what would be helpful for you to know? And you can get real specific. If you want to be well, if I knew the blah, 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 then I could blah, blah, and blah, blah. By the way, I regret to inform you. Guys, what happened? 65%? Now Math 8 got 100%, so they slayed it this time. But guys, we haven't even won a single time. 3A is winning this time. So it's 1-1 for the other classes. I want to encourage you that when we turn in homework on Friday, if we all have it to turn in, like, we need to get our first victory. But, so I'm going to show this again, or sorry, actually, no, I'm moving this, my bad. Like, I meant to move this. We're going to give you 2 days like normal. That's not what I meant to do. Alright, now I don't know what's going on. We're going to give you 2 days to get this turned in, but if you have it done tomorrow, that's when we're going to check it. Ooh, how many years he's been training for a race? Is he a kid or like an adult? Ooh, what shape he's in? Right, is he like real trim and can run real fast? Ooh, how big his strides are. There's a good vocab word. Guys, stride, if you haven't heard that, that's like how big your step is. Like from foot to foot when you hit the ground. Does he take a break? I would for sure have to take a break if I ran 7 miles. Ooh. How many miles he runs in minutes? Feed me some actual data, right? Give me some numbers. Oh, yeah. Talk nerdy to me. Because my walking a mile took 18 minutes by walking, and I'm slow, so am I. So I did 7 times 18, which is 126. Then I took 126 and divided it by 2, which is 63. Look at all this math. Guys, you want to get me excited? Talk about math. Woo! I'm loving this. Keep going. Guys, if you're just now realizing I'm a weirdo, you're a little late on the boat. That boat left the... Keep moving. Keep moving on. So once you type that response, hit next. Now, I want to point out, you can drag this point however you want. Because when I was working through this activity, I was being silly and trying to drop the point on the point, and that's kind of tough. You can drag this point out and then drag it up and down. So when you're working on this one, it says the blue point shows that Jalen ran 4 miles in a little more than 33 minutes. So now they gave us some data, so that person who wanted some numbers, whichever one of you want, they gave us some numbers. Drag the red point to create a model to represent Jalen's run. I got a question for you. As you drag that red point around, and yeah, you know I'm sitting down to pause this, and you're all going to be mad, but whatever. Who can tell me what you're unable to move? Actually, I might need to let all of you. Let's all move on to slide 3. If you're not on slide 3, let's move on to slide 3. So this is showing all of us. So some of us aren't on slide 3 yet, so we need to grab our point and start moving it. We should all end up with lines that look pretty similar. Right, so you're trying to drag your red point so that your line is hitting that blue point. So you don't have to drop your red point on the blue point. You can drag it out here into like open space so that you can see things more easily. What can't you move? Yeah, the blue point, but what about the red line can't you move? What do you do, Eve? The what? Yeah, the red dot stays on the line. Absolutely. What else can't, like...
You cannot change it, like, into a straight line.
What do you mean you can't change it into a straight line?
It's like, you cannot just put it from 4 above and just expect it to be on the blue dot.
So when I go to drag this... now I am pausing you because we're going to write a little in our notes. when I go to drag this, this is stuck, right? This can't move anywhere. And guys, look at the labels. My x-axis is distance. My y-axis is time. Why do we think that we're stuck at 0, 0? Why would that, like, make sense? Lucas?
Because, like, you're going zero time, and you're going 0 miles. So it has to start from there.
Yeah, if you have 0 time, you can go 0 miles. You can't go anywhere.
I have a question.
So, hold on real quick. On your notes paper that I just came around and passed out, where it says proportional at the top of it, I want you to just, in parentheses, put 0, 0. 0, comma, 0. I'm going to show you my camera in just a second. 0, comma, 0. It's right under that yellow folder. And then I will unpause your activity and come around and make sure that we all wrote that down. So 0, comma, 0 is what we just noticed, because this whole activity is dealing with proportional. So go ahead and keep rolling. All of our red lines should end up looking the same. So if your red line is still flat, we need to grab that red point and raise it up.
There's one person that's still flat.
So then move on to the next
On
slide.
this one, do we put like the whole, like, same or just the number?
So scroll up to the top so we can read the directions. Is that the top of the screen? The model you built on screen 3 is shown in red. The equation of your model is blocked based on... Does that make sense when we read it? Yeah, I mean, it doesn't say you have to, like, defend it or write words or anything just to make your prediction, right? And guys, with everything Desmos, if you want to go back and change your answer, you can. You can always go back and change your answer. You need what? It's fine. It's a Desmos issue, not a U issue. Yeah. Wait. Never mind. I'm just checking on where people are at, and Desmos is confusing me. Oh, you had popped back over to slide 1, or maybe this was just delayed. So you guys notice if I didn't drop my red line in an appropriate spot, the equation they give me is different than what a lot of you are getting. So I can go back, fix my red line. Right, with Desmos, we always have multiple chances. And then I can go forward and it adjusts my equation. But y equals something x. What do we think that means here? And how can we use that? We could also use the red line to make predictions.
The names are on, by the way.
Thank you. Does your anonymous name change, or does it stay the same during? Interesting. So you could, like, research that mathematician if you get bored. Because reminder, those anonymous names are all famous mathematicians.
That might be interpret thing.
No, that's probably their real name.
No, Phi.
What?
Like,
Phi.
famous lines.
What? So the interpret the parameters. This is where we start to actually need to write some stuff out. So you could also just look at your graph, guys, and say, okay, 7 miles. I can find 7 miles on my graph. And I can go up to how long I think it would take. And then I can go over to the axis that tells me minutes. A lot of close guesses here. A lot of people are looking like they're around an hour. Ooh, but look at all these different estimate points. So we're not all super close. If your point ends up far away from the line, I think we probably need to adjust our estimate. So don't just move on if it seems like we got something incorrect. Like, we might need to adjust our estimate. So that black point that pops up after you type in your number, that's showing you the number you typed in. Yes, your calculation is right on. Why is your estimate point still way down? Do we want to go back and change it? Get back. I'm curious about this. Not all the way down. Oh, that was your original estimate, wasn't it? Ah. Hey, true confession, I've never done this activity before. This is my first time doing this with anybody. So that black point, I guess, is your original estimate. Will that make sense? So if you go back to slide 1 and think about your original estimate, you don't need to go back and change it, but it's showing you how close or how far away our original estimate was. And what I really care about is what you type in slide 5. What I really, really care about is what you type in slide 5. So I'm going to give you a few minutes. I'm going to actually try to flip my timer and not talk for a few minutes. I really want to see, what does this rate of change mean in this context? Where in the graph does this value appear? Ooh. Where in the graph does that number they gave us show up? And then why does... Ooh, we already talked about that. Why does it make sense that we have 0, 0? All right, I'm going to move this so people don't watch themselves typing on the screen. Because that's weird. You can watch yourself on your screen. You can't just say because it makes sense, that is funny. But you need to actually give a reason why it makes sense. You got to justify with, like, labels. Right? You can say it makes sense because... in 0 minutes, I can blah, blah, blah. So, 8.35. In number 2, this is a really interesting question. Where in the graph does the value 8.35 appear? So, I don't know if it'll tell me numbers if I go move around on the graph. Like, if I click on that blue point, does it tell me what it is? Ooh! Well, that's not 8.35. Yeah, absolutely. Hey guys, you can click on your graph. If you click on it, numbers will pop. Hey! So we found it. What do we think that means? So what's the x? So that first number is always the x. What's the x label? Yeah, and specifically miles. Right? So the x value, that 1, is the 1 mile. So the 8.35 is the y. So what would that be? What's the y label though? Look at the y-axis, look at the label. Minutes, right? So that second number is how many minutes it took us to go. I'm waiting for you to finish my sentence. How many miles? That was minutes. Remember that number? Those are our minutes. So the 8.3 is minutes. When the 1 goes, what's the label on the 1? So that's what we're going to write here. Is 8.3 1. Which that number is is how long that 8.35. Because this point is telling us miles, because x is miles, and minutes is y is minutes. So essentially this says if I stop at 1 mile, it will only take me about 8 minutes. Does that make sense? Guys, check your labels for your x and y axis. This graph is different because most of the time, we would put time down here and we didn't. We put miles down here. We put time up here. So when you look at a point, if you go this way, that's how long it took. And if you go this way, that's how far we went. All right, so when you're looking at the graph, always look at your axis labels. Nice. Now help other people if they need it.
I need help with one.
What do you need? So yeah, we need to flip those numbers. So I have like 1, 8.37. What is that though? Ooh, that's that number. Yeah, just round it. This is just rounded. Oh, so what's the y label? What's the label of your y-axis? Minutes. So that number goes with minutes. When that first number goes with Did you realize to click on the red point? Click on that red point, you're going to find that number that they asked you for. Click on it and stop. There it is. So, you should do it with that. You know there's a left and a right side of this pad? Your dad must have been funky. Maybe it's because we're missing a key or something, I don't know. But so, it should lock in at 1. And it should pop up with that number. The 8.56. See it? So that number shows up when the x value is 1. That's interesting. Water? And when you click on it, what other number does it give you? Well, that's that number. Alright, so one thing I've said like 5 times now, so I should make sure everyone realizes this. Guys, this is rounding. So when it asks you about 8.28, and then you click here and it's more specific, this is the number they asked you about. They just rounded it. So this number is the same as this number. So let's check in with what some of our classmates are saying here. I think 8.31 is the time to the second question where the red dot is on the red line. Oh, and if you have no time, you cannot go anywhere. I think it would have been funnier if you said, if you have no time, you can go no, I don't know. In my head, it sounded funny, and then I read it, and it was actually correct. X means the length, and Y equals minutes. Interesting. X is length, Y is minutes, they say. I agree. I agree. It's 1 mile and 8.37 minutes. That 8.33 means it's about 1 for the distance, and they're still writing. Ooh, I see a math word of per. 8.37 minutes per mile. X equals length, Y equals minutes on the red dot because sorry, but we got to write a tiny bit more. Grab your pencil. When something is proportional, what this really means, and we're realizing this right now. So with your 0, 0, you can put and, or you can draw an and sign. Some of us can maybe draw the ampersand. That's a tough one to draw. Put the fancy and sign. Proportional. So we said 0, 0 because like 0 time, and you might want to make a little note here of this. 0 time equals 0 miles. So 0 time equals 0 miles. And what we know about proportional relationships that we're learning right now is the output, or like the Y, the output, the Y value is actually I'm going to make this easier. I'm going to try to make this definition the simplest possible. The output is input, so X, times some number. The output is the input times some number. So we all have slightly different numbers here. If I go to mine, I have an 8.28. But I want you to write down this, and I'll unpause you so you can write it down. I want you to write down your equation, y equals whatever. I want you to write that on your paper. So like mine would say y equals 8.28x. Go ahead and keep working on this. We have enough time that we can work on this for a few more minutes before answering some questions. So here I'll show my paper again. Output is input times a number. So for example, y equals 8.28x. If you can get to Desmos, the student.desmos.com. Then it's going to actually show you the stopwatch. So they play the video and they show our points for us. Then they actually show us the real data. So when you get to that video, go ahead and hit play and watch it drop those points. And then give some advice. What advice would you give a classmate? I'm going to go home and get some plants for Mr. Trujillo and Mr. Estes. I know that was just a random thought. I might rotate plants from my room to their room, get some sunlight over there, and then come over here to spread some cheer. I should grab my other lamps, too. That's really what I should do. I have hanging lamps that I'm just going to get away with as long as I can get away with. They're like pendant, like from the ceiling, but they just plug in. Alright, so I promise I will try to unpause this again before the end of class. But we got to write some things down to help you with your practice work. So for the next like 5-ish minutes, I want you to talk with your team about each different situation here and see, what do you guys think about it being proportional? We just said that for something to be proportional, it needs to have a 0-0 relationship. So like, if you've been to school 0 days, you have 0 homework, right? If I go buy 0 sodas, I spend $0, right? If I drive 0 miles, I use 0 gas, right? Things like that. And then, could we talk about the output, 1 value, being a number times the input, the other thing we're talking about. So talk with your team about A through F. You don't have to rush, just like go take as much time as you need to talk about A, then move on to B. I'm going to highlight important information up here. You guys can underline or highlight as well. You guys are going to figure out A? So we go to the store and we pay $36 for each video. How much would 0 video games cost? How could I figure out the cost of like 2 or 3 or 4 video games? Your team should be discussing what would 0 video games cost, and how could I find the price of multiple video games. I just feel like hearing you talk about the other ones, I feel like you understand this. You should really talk about that. What do you guys think about that? It is logical, it is not. It is bad. The games change price. No, they stay the same price. So we're always just doing 36. And then times 2 or times 3 times 4. Man, Jesus, you're stealing some of Eli's desk. What is that about? What do we think about that? Yeah, it stays consistent, right? It is, you gotta speak up. You can't hear you. Say that again, but louder. It's okay. And 0 games. Yeah. All right, I think most of us have it written down already. But Mia, do you want to talk about A? No. Aiden, do you want to talk about A? Yeah, so guys, 0 video games would be $0. So we got the 0-0, and then what else, Aiden? Yeah, to find out the cost of 2 games, or 3 games, or 4 games, we would multiply. Right? 36 times 2, or 36 times 3, or 36 times 4. Or if you're buying a lot of games, I guess times whatever. And from what I remember, I think that's kind of cheap in the world of video games. Layla, do you want to talk about B? I know we all maybe haven't had quite enough time. I don't know if you guys got there yet. No? Did anyone get to B? John, do you want to talk about B?
It's not because 56 times 5 is 280, not 250.
So hold on. Everyone take a beat and listen to John. If you haven't done B, say that again, but like speak loudly and slowly.
So, 56, it's not because 56 times 5 tickets is 280, not 250.
What do you think happened that this is lower than what it should have been?
They're giving you a good deal.
They're giving you a deal, which is not proportional, but it's good for you. They said, hey, every ticket's $56, but if you buy 5 tickets, we'll cut you a deal. So this is not 56 times 5. That's why it's not proportional. Yeah, it depends on the concert. I paid more than that for our Green Day tickets, but I don't normally like to pay that much to go see music. I mean, I can see music on YouTube, right? All right, take a couple more minutes, then we'll run through the rest of these. So work on C through F. Guys, and I just changed colors because I felt like it. So if you're trying to match my colors don't mean anything. I'm just changing colors because I feel like it. Seven-minute mile. That's pretty good. My brother, who runs marathons, is normally shooting for like 7 to 8 minutes a mile. That's fast running, right? So marathon running, you want to keep consistent pace. You don't need to push yourself to talk. I like it. Ooh! Kylie's got some good notation. She decided to do P or NP for like proportional or not proportional. So you can do like proportional or not proportional that way. Yeah, but neither of those are great. All right, I'm trying to make sure we get out of here on time and I don't get in trouble with Mrs. Goldring. Anyone want to volunteer to talk about C if View is 4 years older? Deekshita?
So I got an example. If he was 16, he would be 12.
Yeah. Hey, guys, we're bringing it back together to make sure we all got the same answers. I know you made it through all of them, but, make sure you respect Deekshita. So, sorry, what were you saying?
So if he was like 16, then his sister would be 12 because he's 4 years older than her.
Yeah, he's 4 years older. Is this multiplication? No, it's addition. Guys, nobody can ever be twice your age forever, right? That doesn't work for someone. Or if they said 4 times their age, that won't work forever because we each age the same way. So this is not proportional. This is not proportional. Gianna runs at a steady pace of 7 minutes per mile. Anyone want to volunteer to talk about, is this proportional? Kylie, is that a hand? Okay, so we're just messing with the other class then? Okay. Eli? Ooh, it's this word. Steady. Steady pace. She stays at that same pace. Carl just bought a music player and plans to load 50 songs each week. Is that relationship proportional? Any volunteers? Layla, I see you shaking your head. Yeah, so like the music, the songs he has would be like 50 times how many weeks he's had the player, right? So that's a yes. That is proportional. Excuse me. If it's 50 for every, we would multiply. Lucas, you want to talk about F?
Yeah, it's not proportional because the first time we took to level 1, it took her 5 hours. The second time we took to level 2, it took her 3 hours. It's not, if it took her 5 hours the second time, then we'll continue going, that would be proportional.
Yeah.
Because she got better at it, and suddenly it's now down to 3 hours, well, that's not proportional anymore.
I love this problem. Who's ever played through a video game more than once? Like, you played through it, you liked it, you played it again. Like Super Mario Brothers, right? I've played through Super Mario Brothers probably every Christmas vacation for a long time. I'm getting faster because I know the secrets, right? I know the shortcuts. So the first level is kind of tough. You're still figuring out everything. Or think about like the first time you play through the entire video game. But then you get better, you get faster, but that's not proportional. Right? To be proportional, things have to stay the same. So please do your homework, not just for the competition, but for the fact that we need to check answers and take questions. Right? Please bring questions to class. Have a wonderful day. Happy Wednesday. Next week from today, we won't be in school. Woo! A week from today, you'll be at home.